Could volcanoes on Io be the source of Jupiter's supercharged auroras? Scientists at Syracuse University in New York are investigating this mystery. Here, they can make a volcano to order.
I've poured lava over 1,000 times and probably have seen more lava than a lot of volcanologists.
Professor Bob Wysocki runs the Lava Project. He uses his homemade furnace to replicate the geological conditions on other worlds. Tonight, he's gearing up to investigate how volcanic activity on one of Jupiter's moons might fuel the planet's deadly radiation and light up its auroras.
I'm the head janitor as well as the head theoretician, so I get to do everything. All the shoveling, all the fixing when the machine dies.
Bob heats basalt rock until it melts.
We're going to charge the furnace now, and this is simply just putting more material in to melt overnight.
The furnace burns at 1,300 degrees centigrade. It takes an immense amount of energy to melt even a small amount of rock. So where does Io get the energy to fuel its volcanoes? It's all down to Io's immense and malevolent neighbor, Jupiter. The planet traps Io in a gravitational tug-of-war with other orbiting moons. Inside Io, the relentless push and pull from Jupiter heats up the interior to melting point, creating smoldering currents beneath the surface. As the pressure builds, the lava finally erupts through the moon's crust. It shoots scorching fountains of lava up to 1 kilometer high and floods the frozen surface with molten rock.
Okay, Jeff, you ready to go? Yeah.
In Syracuse, Bob is ready to pour the lava.
We are just that one step below what comes out of a volcano in making and replicating what happens in nature.
Well, we're doing an experiment today to try to better understand what happens when ice meets lava.
Geologist Jeff Carson is joining Bob to see what happens when volcanoes erupt on Io. Io is extremely cold. Its surface is made from sulfur dioxide that is frozen solid. Bob monitors the furnace while Jeff examines how lava interacts with the ice.
The physics that govern the way the lava flows form, the way they cool, the shapes they take on, these are all the same on other planetary objects, but the same basic physics applies.
Scientists believe that the hot lava pouring out of Io's volcanoes onto its icy surface has a direct effect on Jupiter's radiation.
Moving on to the ice, a bunch of bubbles are starting to form. You see a completely different style of behavior of the lava here. I'm going to step back actually because I can feel the heat so intensely here. But those bubbles are forming because water vapor is being produced, boiling the water in the ice, the vapor is escaping through the lava and blowing these beautiful bubbles. It's a really good analog for what could be happening on other planetary objects like on Io.
The hot lava causes the frozen ice to instantly vaporize into clouds of steam.
On a place like Io, it would be sulfur that's being vaporized and sulfur dioxide making bubbles and being released into the atmosphere.
Scientists now think that vaporized sulfur dioxide is the key ingredient to explain Jupiter's extraordinary auroras. Io's